Welcome to AU Group Electronics. Today I'm going to demonstrate the function for AU OBD2 CAN Simulator. On the screen I have the basic structure of the setup for the OBD2 CAN Simulator. So in the middle we have the simulator, and on the RS-232 side we have a cable, the USB to RS-232 converter cable, which can be connected to a PC with USB port. And then this PC can be used to show the remote terminal GUI. On the bar side, we have a OBD2 CAN cable, and then this cable can connect to OBD2 CAN network. And also on the bar side, there is a power jacket, and this power jacket is dedicated for our power supply. It's 14-volt AC/DC power supply. And now, if you look at my screen on the bottom left side, I have a camera showing the real device. So this is the OBD2 CAN Simulator, and as I show on the picture, the USB cable, and this is the bus side. When I unplug from the bus, it's powered off. When I plug back in, it power back on. So I can press the button up or down button to control the step, or the menu button to control the warning on or off. Now let me open the remote terminal. So right now the remote terminal is open, but the serial port is not connected yet. So we choose the communication common 1 because this is the communicate serial port I'm using right now. Click connect. It will connect to the serial port, and now we can use the remote terminal to see the simulated data. So on this GUI on the top left hand side, first you see is a disconnect and then exit. When I click disconnect button, it will disconnect the RS-232 connection. When I click again, it will connect back on. If I click exit, this GUI will be, the app itself will be exit out. So if I click exit, it's disappeared, it's closed. But if I click the terminal again and move back over here, it's because it's remember the serial port, so it's connected automatically. So on this corner we see the product ID, the firmware version. Right now the most current firmware is 0.1D, and the serial number, which is 23017. This serial number is very important because when you, for example, when you later on you have the you have received your simulator, and later on you want to upgrade the license or update the firmware, we always need you to provide the serial number to us. That's where you find it, or you can find the serial number from the device itself. It says SN blah 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 blah. Okay, and after the serial number you can see the CAN baud rate. We support two different CAN baud rate, 250K and 500K. When you click 500K, it will automatically switch to 500, and then you can click 250K, it will switch back to 250K. And then this is a firmware build version or build number. so you know what is the firmware you have in the device itself. This checkbox is one wing, which means just like some of the customer, they say, oh, this simulator, I always want to keep the win number consistent. I don't want the win number to change, so they can check this checkbox. But if you want to use for some application, like you want to check, you want to verify the win number, or you want to testing for the win number for your application, you uncheck that, and then when you click, when you add different step, the win number will change. For example, if I move to 0 and look at the win number over here, especially on the last 3 or 4 digits, you will see it's 000. And then if I move to like 90, the win, because the win number doesn't change, because right now I have the script function on, so I disable the script function, and then the win number will change based on the step value. So for example, if I move all the way to 100, the last 3 digits change to 100. The previous those number before that doesn't change. So each step, if I move the step over here, each step will provide you a different win number. Okay, and then the checkbox on the CAN off, it's a switch box, it's a switch button, like a 10 on or 10 off the CAN bus. So on this window, I have termite as a serial communication port over here. If I connect that, you can see the CAN bus is off. If I uncheck the CAN bus, and then you see the CAN bus turns back on. Connect that. The CAN bus turns back on, and because we have so much data here, you can see the scrolling. Let me scrolling back and forth. See the CAN bus is on. All right. Next is the product type. Our OBD2 CAN Simulator has has 2 different functions. One is supports classic OBD, it's J1979, and also it supports OBD on UDS. So you can just choose any one of it and then switch between these 2 different protocols. After that is CAN ID. We support both 11-bit ID and 29-bit ID. As usual, you can switch from the drop-down list. After that, there are engine source address, transmission source address, and ABS source address to select from. Just choose anything from the drop-down list. The only thing you want to make sure is you don't want to have the same source address for those for engine, transmission, or ABS. For example, right now I have 18 as the transmission source address. If I check, okay, let me see. If I check 1F, the source address for transmission change. If I check 2F for ABS source address, it changed to 2F. If I check that, as long as those source address are not identical, it allows you to do that. Otherwise, you will see, oh, it's conflict. Now I switch back the source address. The drop-down list after that is the ignition type. We support spark ignition and combustion ignition. And the DTS format for OBD on UDS only, you can either choose J1939-73 or J2012DA. Okay, and after that is the warning checkbox. Because we support engine transmission or ABS, you can individually control the diagnostic code, like engine diagnostic, transmission diagnostic, and ABS diagnostic. Or this one is the engine permanent diagnostic code, and J1699, and or you can turn live CAN on or off. So those three DTC, like engine transmission and ABS DTC, can be controlled by this warning control button. If I uncheck the warning, all three will uncheck. If I check the warning, these three checkbox will turn on automatically. But you can individually check or uncheck over here. After that is the slide bar. We call it slide bar, or we use the slide bar to control the simulating data. Like on this one, at 0 it's a step 0, and all the way you can go to step 100, which means in the simulator firmware we actually, because there are so many parameters, so it's very hard to have all the parameter controlled by each input value. So we simplify this input using the slide bar. So all the parameter actually, by the SAE definition or ISO definition, there is 0% all the way to 100% defined range. And then if it's at 0%, that's a minimum value. If it's at 100%, that's a maximum value defined by SAE or ISO documentation. You can either use the mouse to control that, or you can use, once you click the slide bar, you can use a keyboard, like up to increase one step at a time, or you can use page up or page down to increase or decrease 10 steps at a time. Or you can page up, home or end button on the keyboard. Press the home button, it goes to 0. Press the end button, it goes to 100%. So that's a quick way for you to jump back and forth. Or if you wanna go to specific step, you probably just have to use the up or down button to control that. After the slide bar, there are 3 push buttons. This is those 3 buttons has exactly 3 exact function as the 3 buttons on the device. Like the menu button, it controls the warning on off, or this is the same thing. Menu button on the device has the same function. The down button is increase the step value. The down button is decreasing the step value, and up button is increasing the step value. After that is a dynamic checkbox. The dynamic checkbox, it's when you are testing something. For example, you don't wanna, I wanna see some value change from certain percentage to 100%, or you wanna change that. You don't wanna keep press your mouse or keep press the up or down button. You can use the dynamic mode. When you check the dynamic mode, the slide bar, you can see that the slide bar will automatically moving downwards, and then when it reaches to 0%, it will automatically moving towards to 100%. So it's going to automatically moving back and forth. When you uncheck the dynamic box, it will automatically return back to the original starting position. So I pressed again, going done. And then, for example, if I move all the way to here, I want to see it goes to 0%, and then once it reached to 0%, it moves up to 10%. And let me go back to here. Because it's moving up, and right now it moved towards to 100%. When it reached to 100%, it moved down automatically downwards. And after that, let me uncheck this dynamic box. After that, it's the quiet box. This quiet box is silent buzzer for the simulator. So after I click the quiet button, quiet box, when I click up button, you doesn't hear any beep sound, right? If I click back done, it doesn't do anything. So uncheck that if you really want to have a feedback. This is a warning, the same function as a menu button. So this is basically the control, how you control the output for the simulator. And there is if you look at the product ID, right now the product I'm using is a Vehicle Platinum Script Edition. For all the Script Edition, the script button over here would be enabled. If it's a non-script edition, this function would be disabled. But since it's a script edition, the script can be turned on. Just click this button. Click the script button over here. The script function, we have, like I said, there's so many parameters supported by our OBD2 CAN Simulator, but for majority of our application, majority of our customer want to change some of the 6 of the parameters, like engine RPM, wing number, engine runtime, like engine hour, or vehicle speed, like odometer, or so the voltage. So those 6 parameters can be individually controlled by those input box for the script edition, and all the other parameters still controlled by the slide bar. So let me do a quick example. Let me clear all those inputs. And for example, if I want to change the engine RPM, let's see, I want to change the engine RPM to 5,000. So I type 5,000 and click verify and send. Notice that the engine RPM right now is 29. It's around 3,000, right? So if I want to change engine RPM manually, but I don't want to change any other parameter, I just input 5,000 over here and then click verify and send button. After that, the engine RPM over here changed to around 5,000. It's fluctuating because we have the white noise enabled. If I uncheck the white noise, it keeps stable at 5,000. So the white noise is like mimic the real situation. So you don't want to like a straight line. You want to fluctuating a little bit. So 5,000, it gives you a fluctuation, a minor, very tiny fluctuation for the value. And then, for example, if I want to change the engine hour, I see the engine already ran 1, 2, 3, 4, 5 seconds. And let's see the engine hour. click verify and send. So all the engine hour related information over here is changing back to that, or very close to 1, 2, 3, 4, 5 seconds. Again, we can change the vehicle speed. I see I'm running 110 km per hour. You see the vehicle speed is 110 km per hour. Now let me uncheck the white noise so you know, so you can see the exact value. Right now the engine, the vehicle speed is 110 km per hour. And the same thing over the odometer. You see my truck already run 6,009 kilometer. I can click verify and send. So see the vehicle odometer display is changed to this value. Now let me using our interpreter to see what is output value from our simulator. So I click clear and then connect. So disconnect again. You can see our RPM is 5,000. That's exactly the output. Mile per hour is 68. The vehicle speed on the speed output for our interpreter, the unit is mile per hour, but on the simulator itself it's kilometer per hour. So when our vehicle speed is 110 km per hour, if you convert to mile per hour, it's going to be 68.35 mile per hour. All right, so then same thing happened for the voltage. For example, the voltage right now is 12.6 volt, right? You see my truck is running 24 volt. So I change that, verify and send. You can see the voltage change to 24 volts. So that's how we can change the simulator output by individually control those 3 buttons. And the same thing for the win number, but we do have a calculation behind the simulator. So if your win number does not follow the win check verification methods, it will pop out a message. It will pop out a message. See, I just randomly click something. I see verify and check. Then there would be a warning message. See, the win must consist of 17 characters. So it's an invalid input. This feature makes sure that you are not messed up the win number. You are actually inputting a valid win number. Okay, so for those change, it's just, you don't need to change one at a time. You can change multiple parameter at a time. So the changing, for example, I can change to 1,000 here, and then say 2,000 here. Speed is 50 km per hour, and odometer we see is 80,000, and then the voltage, see, right now it's running 18.9 volt, and then I click verify and send. All these parameter is going to change to the input value that we input over here. See the RPM, engine hour, vehicle speed, voltage, and odometer. So if you pay attention, you probably see whenever you click, you have value here, and then you click verify and send. Those in this window, you're going to see some kind of command. That's a script. That's a script generated automatically. So you don't need to, each time you want to change something, you don't need to enter manually. You can copy those, like you can copy those code, those script, and paste it into a text file. And then, for example, I can paste over here and save it. And then when if you don't want it, you can just modify that. So that's one of the feature. And then we have we also have implement some demo code, like segment script segment over here. The first code is key on, engine off. So we click here, and then it shows you what is how you write the code. I mean, how you write a script. For example, the first one, for each line, when you have a semicolon in between before, it's a comments. Now you can turn off the CAN bus. Use AT command space CAN bus equals to 0. All right, to turn it on, you can use AT space CAN bus equals to 1. And then you can turn on or turn off the white noise. So instead of click the checkbox button, you can use the script to control the white noise on off. It's AT command AT space white noise equals 1 to turn on, and AT space white noise equals 0 to turn off. Okay, after we also have like a loop function. We use repeat anything for 10 times or 5 times. You put a 5 in the repeat. Okay, so that's the code for engine on, key on, engine off. And then if you want to crank, like cranking the key, starting the engine, so you can use those, that's a demo, that's a example code here. Like you can change the RPM, change the voltage. So those number, one thing you want to pay attention is like RPM equals something. It's not the for example, you want to put engine RPM equals 1000. You are not input AT space RPM equals 1000. We have a dedicated or two-way verification. So instead of create by yourself AT RPM equals something, you can just for example, let me click 1000, and then click verify and send. That's how you generate code or script for that. And then you can copy this into your, select all, and then copy, and then paste into your script file. After you save that, you can use you can save this script into a file, and then load a file. Let's load a file, and then click that. That's a demo code, that the demo script file that I wrote earlier. And then you can run the file. So if I click this turn on the script, you're probably able to see, or you will recording what is the value on the output OBD2 simulator. So this this is a combo interpreter output that also designed and manufactured by Au Group Electronics, and it's not the same as It's not the same product as the simulator. It's OBD2 and Gen1939 and J1708 combo interpreter. We use this interpreter to capture whatever data on the canvas. Right. So while the script is running, we can just take a look of the demo file. So as I said, to turn off the CAN bars, you can use AT command CAN bars on, CAN bars equals 0. To turn on, CAN bars equals 1. So this, whenever the script ended, it will show you script finished successfully. That's the status. And then because we have noticed that we have AT space, CAN bars equals 0 here. And now the CAN bus is off. This CAN off is checked just by running this code. So we want to turn on the CAN bus for the next run. So you can either uncheck over here, or if you are going up at the beginning, we have a code to turn on the CAN bus. This is a turn off. Over here we have the CAN bus turn on here. So make sure you have you're not generating the code by yourself. You always use this script window to input the value here and input the value here, and copy and paste the script code into a text file and then save it. Save it, and then you can load the file and then run the file. So input the desired value here, and then click verify and send button to click verify and send button to generate the desired code, and then copy that into a text file. Once you are satisfied with the script text file, then you save it. And once you save it, you can reuse this script file. Like load the file, double click to open that, and then click run file. That's how you use a script function to run the file to generate the output value for your testing purpose. That's all for the demonstration. If you have actually all the other, that's all the demonstration for the script function and for the control capability. All the other area are for displaying, and for each edition, for different edition, Engine Basic, Vehicle Platinum, each edition you probably have some of the value, some of the display portion grayed out. That's because that function might not be supported by your simulator. But for those DTC, if the warning is turned off, you will see no diagnostic code. If you turn on the warning, you will see all the diagnostic here, and some of the output window showing like for example over here, it's for permanent diagnostic code. So there is no diagnostic code here because the engine permanent diagnostic code is unchecked. So if I check here, you will see one diagnostic code, and then if I change the slide bar, you will see different diagnostic code here. That's how we use the remote terminal to control the output for the simulator. But the simulator itself, the device itself, actually you can use the app down button to control the value. But if you want to use a script function, you will need the remote terminal GUI. That's basically the overall for the function of AU OBD2 CAN Simulator. If you have any question or any concern, or if any of the parameters that you need are not supported by our current firmware yet, always contact us, and then we have the capability to implement more parameters for you. Thank you.